All right, quiz review. So just going to go with it being all typed out instead of writing it so it's easy for you to read. Where'd it go? There it is. All right, so here's our problem. In a recent survey by some math department, teachers asked their students if they drive to school each day. Of the 1,575 students, 350 were randomly sampled. That's important. 168 said yes, 182 said no. So, it says, construct and interpret a 95% confidence interval for the number of students who said yes. So, we start off by just saying, what is P? Okay? That is the true proportion of students who drive to school each day with 95% confidence. Okay? Now again, just within that wording, just as long as you get the general gist, it's always going to be the true proportion, and you're really just getting that from, students who said yes. What's the question? Driving to school. So just as long as you put something to that effect, we're good to go. Not going to be really picky, just get the general gist. Okay, what's your plan? Okay. One sample, Z interval for P if the conditions are met. Right? We already were told it's random. Right here. Okay, so we're good to go there. And then your large counts. You take N times P, so number of students, that's N right here. P, where did we get 0.48 from? Well, if you do 168 divided by 1575, you will get 0.48. Okay, so remember, it's just like getting a grade on a test. The top number is your score, the bottom number is what the possible was. So there was a possibility of 1,575. I'm sorry, my bad. I just screwed that up. It wasn't 1,575. It was out of 350. That makes way more sense. That's about half. Sorry about that. So there were 350 students sampled. 168 said yes. All right. So almost half. So we take that number, P, and we multiply it by N. And it's 168, which is greater than or equal to 10. We're good to go. Then we take 1 minus P. So that would be 0.52 times 350. That gives a little bit bigger, 182. Still greater than 10. We're good to go. Now comes the math. So you just have the formula. Okay? It's P plus or minus Z score. Now where did that 1.96 come from? It comes from our blue manual that tells us that for a 95% confidence interval, we use 1.96 for Z. And then we just plug in our numbers. Here's P, 1 minus P, and N. And that gives us 0.48 plus or minus 0.05. And that's a range of between 0.43 and 0.53. So between 43 and 53%. All right? And then our statement, which is not changing. We're going to use the same statement over and over. We are 95% confident that the interval from 43% to 53% captures the true proportion of students who drive to school each day. And that's it. Hit pause if you need to. Moving on. Now, what happens if the interval is changed to 99%? Okay? The interval gets wider. Okay? So, larger confidence, write this down, larger confidence, wider interval. That's a key concept. What would happen in the interval if the sample size was changed to 250? It would not be as precise. So, larger sample, more precise. Consequently, not going to write it down, smaller sample, less precise. All right, moving on. Number 2, in a recent survey by Summit's Math Part, asked students who spend more than 2 hours each day on social media. The 2250 students in the population, 400, that's my N, were a randomly sampled. 220 said yes, 180 said no. Now, we can't just say 220 is our X, because we got to look and see, are we all looking for yes or no's? And it says, construct and interpret a 95% confidence interval for students who said yes. So that's my X. Now, I'm going to take X over N, which is 220 divided by, I'm going to do it right this time, 400. You can see that that's going to be a little bit over 50%. So, state P, the true proportion of students who spend more than 2 hours a day on social media with 95% confidence. Okay? Same concept. Just take the words true proportion and then fill in the information from the problem. Now, what's my plan? Again, one sample, Z interval, if the conditions are met. That's going to be the same statement every time. Random, it was random in the problem, so let's give it. Now, my P is 0.55. Said that before, it's going to be lower 55%. Take that times N, so N, P, gives me 220. We're good to go. So 1 minus P is going to be 0.45. Still bigger than 10. Good to go. Fill in the numbers into the formula. P, 0.55, plus or minus 1.96. Okay? And again, remember, it's 1.96 because it's a 95% confidence interval again. If we use a different confidence interval, then we would use a different z-score. We plug in P, 1 minus P, and N. That gives us 0.55 plus or minus 0.05, which gives a range between 0.5 and 0.6. Our statement is going to be the same statement. We're 95% confident that the interval from 50 to 60%, and then what does it do? It captures the true proportion of students who spend more than 2 hours a day on social media. Same concept, same sentence. What would happen if it was changed to 99%? Same as before, it would get wider. If we change it to 90%, it would get smaller. What would happen if it was changed to 500 students? Well, then we get more precise because we increase the sample size. And that is it.